So how can I back up my PostgreSQL databases? So custom scripts, pgback REST, WAL-G, PG Pro Backup, Barman. Okay. So we're technical people, and we have a tendency to focus on the tools, the means. Okay, but actually, without goals, means are useless. So we should be asking ourselves, what are the business continuity goals of my PostgreSQL infrastructure? And then when we have goals in mind, we can think of means. So any tool is fine, as long as you implement disaster recovery procedures and you develop a disaster recovery culture in your company. Okay? We started Barman 8 years ago, and the goal of Barman was to promote disaster recovery culture among PostgreSQL users. And the fact that there are many tools now that invest in both backup and recovery procedures is, the best compliment we could get out of that initiative. Okay, so any tool is fine. Of course, today I will be talking about Barman. Okay, because Barman is, I'm one of the founders of Barman. Okay, so my name is Gabriele Bartolini, and thanks for being here tonight in Bologna. So I'm an open source passionate, and I've been, I was a programmer. First time I used Postgres, it was in 1997. Then I switched to MySQL, and then went back to Postgres for good in 2000. I'm one of the co-founders of both the Italian PostgreSQL user group and PostgreSQL Europe. Okay, and Magnus is the president now of Postgres Europe. Actually, he's always been the president. Yeah, so I'm also head of global support at Second Quadrant. And as I was mentioning before, I'm one of the developers and the co-founder of Barman. I came up actually with the name Barman. Okay. Most importantly, I've become an entrepreneur and then a practitioner of agile methodologies, lean methodologies, and DevOps methodologies. I really believe in DevOps and making the workplace a better place for everyone that works in IT, especially in teams. Okay. Today we released Barman 2.8, and it's Friday the 17th, so we're not scared about that. As our friend Gene Kim says, we shouldn't be scared of releasing software. Okay, so as we deploy stuff on Friday night at 5 p.m., as a few weeks ago we switched data center at 5 p.m. on a Friday. We're not scared of releasing Barman today. Okay, so this is the best release of Barman so far. So let's go back to goals. I'll be brief today because there will be a lot of practice. Okay, I'll be cheating actually, but so when we talk about goals in business continuity, we have actually two metrics only. Okay, one is recovery point objective, so RPO, and that's the amount of data that the business can afford to lose, and the answer is always 0. Okay, so everyone wants 0 data loss. Okay, and recovery time objective is the amount of time it takes for us to recover after a failure, an outage. Okay, so these are the two most important metrics to keep in mind when we design business continuity. If you want to know more, there's a video that I delivered 2 years ago at the Italian PG Day that explains all these concepts. Okay, so but so far we just for today we just worry about RPO and RTO. Today we will be following an incremental approach. So and that's the advice I give you when you put this in production yourself. Okay, just start simple and then build on top of that. We will be focusing mostly on disaster recovery because, you know, business continuity is also about high availability. We don't talk about high availability today, but mainly on disaster recovery. So what better approach than a practical one? Okay, so that's what we will be doing today. For this talk, thanks to Rubens and Anna, we have written an Ansible playbook that is open source. It's GPL. It allows you to test everything that we've done in this talk. Okay, it sets up 4 machines using Vagrant. So 4 small machines in your computer, for example, and we will use Ansible to provision PostgreSQL 11 and Barman 2.8. Okay. So I usually come up with band names and, you know, artists. Even in the book, the PostgreSQL book, I used to use AC/DC band names, but, you know, from the moment they started to change singers, and unfortunately some of them passed away, I decided to change band and use the Beatles. So we will have 4 servers. One is John and one is Paul. The other ones are George and Ringo for Barman. So the first 2 will have Postgres 11, and the latter 2 will have Barman. Okay. We have set up an internal network with Vagrant. So we have, you know, the point 10 server is Paul, point 11 is John, George is point 12, and Ringo point 13. Okay, you know, it would take probably a day to do everything, but the starting point is this. With Ansible, we have set up the 4 machines, already initialized PG data with data checksums. So, and that's an advice. If you set up PostgreSQL in the cloud, for example, always remember to initialize that with data checksums. Okay. We have enabled archive mode, although we won't use it today. We have set up syslog for the logs, and we have already set up PG-HBA to allow access using MD5. For simplicity, we didn't worry about SSL. We suggest that you use SSL only in production, okay, especially after GDPR is in place. We have also prepared a PGBench database. So Paul and John have a running PostgreSQL instance, and we have already performed the SSH key exchange between the servers. Okay, so all of this is done. If you want to know more, you just explore the Ansible playbooks and you play them yourselves. Okay. What we will be doing today is simple. You know, we will have a PostgreSQL database in the Paul server. We back it up on George using rsync via SSH. We could use streaming replication, but we start with rsync because we can use incremental backup using hard links, and we can use also parallel backup in Barman. Okay. Then we will issue a Barman recover command to set up John, and then we will attach it to Paul via streaming replication. Then we will create a synchronous cluster with John, the first synchronous standby, and Barman as fallback server. These allow you to achieve RPO 0 within the same data center. Okay, of course not in another data center, but 0 data loss. In case Paul goes down, you have your data written in John, all your transactions. So they have to be very close to each other. Can you all hear me? Okay, good. Then what we will do, we set up Ringo. Ringo is usually, you know, always left at the end. And we will set up a geographical redundancy, even though they are in the same data center, in the same machine actually, so it doesn't make sense, but at least you see how it works. Okay. All good. So ready to start, okay? So it's not going, okay, I was saying I'm cheating, okay? It's like a singer that plays playback. So I have recorded all the steps using a very neat tool called AskKinema. I think it's called AskKinema. Yeah, so yeah, I'll move to the console now. So we have roughly 30 minutes. Yeah. So basically, this is what I'm going to do now. So sorry, wrong shell. Okay. So basically, this is how you spin up your machines. You execute Vagrant app. Vagrant app now is creating using VirtualBox 4 machines in your laptop. So I use my Mac to do this. I'm using CentOS 7, so the latest CentOS 7. You can sit. There's a lot of room here. Okay. And then, I executed Ansible playbook. So basically, this is, very fast now. So I've installed from scratch the 4 machines. I recommend you always use this approach. This is repeatable, it's testable. Everyone can actually repeat the same things from scratch. That's the foundation of the DevOps concept, okay? And we don't do anything manually, okay? Everything needs to be put in source code, versioned, and we must allow everyone in our team in the world to repeat the same steps. That's how everyone learns. That's how companies learn, grow, and organizations as well, okay? So it's important. We all want to have fun when we work, okay? That's a foundation, again, another foundation of DevOps. So now we have the 4 machines ready. I play the PostgreSQL installation now. Can you all see? So I connect to Paul, I become root, and I check if PostgreSQL is running, okay? I executed system control status PostgreSQL 11. Then I become Postgres, I check my PG data, okay? I connect as Postgres, and I check the settings. This is a query that I used to check all the settings that I have changed from default in the configuration file, okay? Ordered by line number. So these are, all the things we have changed. There's syslog, there's archive mode, archive command. They're very small machines. So what level is important? We just, as Leonardo was mentioning before in his talk, that's the maximum level. So we put in the WAL files information about logical replication as well. And we've got these databases. PGBench is there, but it's empty. Okay, do you know what PGBench is? No, okay, PGBench is an application that comes with Postgres that we can use to perform OLTP-like benchmarks. But also it allows us to write our own queries, custom queries, to test, to measure the performance of the PostgreSQL cluster. So it's everything. If it's measurable, if we measure a process, that's the first step towards improvement, okay, and towards decision making. So never size your PostgreSQL machines without proper benchmarks. Okay, always benchmark your databases. Okay. So as you can see, pghba.conf is already configured to accept connections with or without SSL from the internal network that we have created in Vagrant, okay, using passwords. So this is pgbench help page, and I will initialize pgbench database and then run it for 10 seconds. So I will run pgbench for 10 seconds. That's the standard set of queries. What I will be doing now is to launch a screen session and execute, let pgbench run in the background, for an hour. Okay, so that I generate workload in the Pol database. Does it make sense? Okay, so now it's time to create the users. So we have to create 2 users for Barman. One for coordination, so to perform checks if everything is fine, to check the status of the cluster and so on. And the other one for streaming replication that we can use for wall streaming, for example. Or if we want, we can use it also to perform backup using pgbase backup. Okay? So I generate a password randomly using pwgen. Okay, I create users. This is the help page for creating users with password prompt, and for simplicity I use a super user privilege for Barman. And then I create the streaming replication user. So they're both there. What we do now is we go in George. George is the Barman server, and we set up pgpass. Okay, never use passwords in your connection strings. Okay. Okay, yeah, this doesn't work. Yeah. So basically, there's a video, okay, of ASCII that is in the you find in the slides. So basically, what I did is add the passwords in pgpass. Okay. I can actually show you live. That's what I did. Okay. pgpass. Only accessible by Barman. Okay, in the home directory of Barman. Okay. Let's go back. So now I check if I can connect to Postgres as Barman user. And it works. And now I connect to the streaming replication database with the streaming protocol with identify system. Okay, so we have created the users. So Barman is now able to connect to Postgres both via standard libpq and via streaming replication. Now we will proceed with Barman, and we will get to create our first backup. Okay, so we connect to George. We become root. Okay, it's important to know that with Barman, I can use root as well to execute commands, because it will set UID to the Barman user that is specified in the configuration file We'll see it shortly. So I'm using the packages that as second quadrant and as community you can find. Okay. This is an important piece of information that we have released today. You can see now a Python Barman package. That's a library. Okay. From today, we have refactored the code of Barman so that we have a library that is shared with Barman CLI. I don't know if you're familiar with the Barman CLI package. Okay, somebody of you has used it. Basically, Barman CLI is now included in Barman. It's the same code base. And there are some news I will tell you about at the end of the talk. There's a reason for this, okay? So Barman 2.8. This is the man page. I encourage you to read the man page in Barman. There's also man 5 for the configuration file. And these are the files that the package, both RPM and Debian, installed for you. So one is the maintenance cron. So every minute, Barman cron is executed, and that's set up by the package. You don't have to do it yourself. And the other one is integration with log rotate. So Barman log is in var log, and it's rotated according to this policy. So the log file is there, so right now we don't have any server installed. So list server is the command that shows the servers that are installed. So now we will create a configuration file. So we enable compression, we set up immediate checkpoints, and we also set up minimum retention policies. Then what you can do is simply copy the SSH server template and then modify that if you want to add a server in Barman. Alternatively, you can use the streaming one as an example to set up streaming replication. So this is the edit. Of course, here it's a bit messed, but I'll show you in a moment the configuration at the end. So we set concurrent backup. We set streaming archiver. So we tell Barman to expect WAL files via streaming replication. And we inform Barman that we are using PostgreSQL 11 here. Then we enable the poll server by renaming from .disable to .conf. And now we can see the poll server installed. So it's very simple, as you can see. This is the most important command in Barman. It's Barman check. It's the reason why we developed Barman in the first place. Barman check is the command that allows us to integrate the backups application in a monitoring infrastructure. Okay, so if there's a problem, we are immediately notified. And also we can use Barman check to drive us in the installation process. So now we become root. We create the slot, replication slot. Okay. So the cron command makes sure that the WAL streaming process is up. So as you can see now, all the greens are. Barman is streaming, so we can use the Barman replication status command. And then what we are going to do now, with show server we see all the settings. We ask Barman to force a switch WAL and to wait for the archiver to receive it. Okay, so basically Barman asks Paul to switch the WAL file, and waits for that wall to arrive to Barman. So once we have that, we can ensure that wall archiving works. So yeah, this is what I was saying before. I'm root. This is how you check. So now everything is green. Okay. There's also a Nagios output for the check command. So all you have to do is barman check dash dash Nagios, and the output can be used with Nagios. So now we require the presence of one backup. So barman check fails. So for example, if you have placed barman in your Nagios infrastructure, you get a red alert now because there's something not working. Okay. So all we have to do now is take a backup. So barman backup poll, that's the command that we need to run. With barman list backup, we get the list of backups that we have in the server. And with barman show backup, we get this kind of output. So we get details about the backup. Okay, so now, yeah, we have our first backup. So from now we are protected. PostgreSQL is creating, there's pgbench generating workload on Pol. Pol is producing WAL files. They are shipped to Barman via WAL streaming. So in case of disaster, we can recover at any point in time from the end of the backup. Okay. So now we will see the incremental backup in action. So we take another backup. And because pgbench basically is a very small database with just a few tables, we won't appreciate much incremental backup because pretty much all tables are updated. But we can see that basically we had a gain. Basically, we saved about 14% of the backup size. So it's very minimal. But with some of our customers, especially with very large databases, the gain is also can be about 60% every time there's a backup. Okay, so with weekly backups, especially if it's a 20 terabyte database, saving is relevant. So we are using hard links. So that's how Barman performs incremental backup. So it's not at block level. So what we are doing now, we are entering the Barman directory for base backups. And we are performing a simple du command that shows, so this is the format of the folders. So that's what we see with du. If we expand the hard links, we see the actual, actually what we see. Basically, this is the amount of space taken by the backups. This is what we see in Barman as global space. So now it's time to perform our recovery. So recovery is important because it's the ultimate test that allows us to check if the backup worked. So the first step to do, we stop Postgres in John. Okay, so we have John on the other side. So we shut down Postgres and we issue a Barman recover command, a remote recovery command that wipes out that directory. Okay, so this is the command we are executing. So Barman recover, we ask Barman to write the recovery.conf so that we use Barman WAL restore, so we fetch WAL files on demand. Then we enable standby mode in recovery.conf, which enables hot standby, basically. In this case, we use two jobs in parallel to perform the recovery. And with the remote SSH command, we execute a remote recovery. Then we say, use the server poll, use the last backup, and copy that in var lib pgsql 11 data, which is the default directory. And this is what happens. So now we connect to John. We analyze PG data. And this is the Barman recovery info file, which is used to perform incremental recovery in case we want to overwrite this directory. And these are the differences between the PostgreSQL conf files. So we basically restore the original PostgreSQL.conf file that was in poll, so that they're identical. So this is what Barman prepares. Okay, so it's a restore command. So we are using Barman will restore to get WAL files on demand from Barman. So now we connect again in John, and we start Postgres. And we look at the log files. So basically now, as you can see, we are restoring WAL files taken from Barman. So we are not using streaming replication yet, but we have hot standby. So we can perform read-only operation on that server without having yet streaming replication, okay? Just by using Barman relay system. So now we stop Postgres. This is, we add, parallel fetching because we can use Barman WAL restore to archive to use parallel fetching and compression, and we restart it. Okay. And now we add streaming replication to the game. So it's simply a matter to modify recovery.conf. Okay, yeah, we need to create another user. We call it streaming standby. So we add pgpass again, like we did before. And then we check that the connection works. We add hot standby feedback. And for symmetric purposes, it's good that we add it to poll as well. Okay, so that the idea is to have both PostgreSQL configured the same way. And we add primary con info, which tells the standby to also connect via streaming replication to poll. So what happens here is that we fetch WAL files from Barman, and then we start streaming from poll. So now we have a master, a primary, a standby, backed up from Barman in streaming, and then using Barman as fallback for WAL replay. Now we add zero data loss to the game. So what we have to do is simply add an option to poll. We add synchronous standby names. So we tell here, okay, let me show you. So this is what we need to add. So we tell that the first standby is the first synchronous standby is HA, which is the standby, and then barman as fallback. So in case the standby is put down for maintenance, the poll server writes synchronously to barman. So we have zero data loss cluster. You know, you need at least 2 standbys, or 1 standby and barman to implement synchronous replication. So now, as you can see, we've got two wall receivers. One is synchronous, you see it up there. And one is potentially synchronous. So that's barman. Okay. So now the last bit is about geographical redundancy. So is it all clear now? We've got Paul. We've got George as backup. Then from George we created John. Then we put them in streaming replication. So we've got a primary standby and backup cluster. And then we've got synchronous replication. So with just these 3 servers, we've got zero data loss. What we can do is share barman with other PostgreSQL instances in the same data center. And you can achieve the same results. Now what we do is set up Ringo. Okay, so we've got Ringo, and we set up Ringo so that it fetches backup data from George using SSH. And so what happens is basically by itself, barman starts syncing the content from George. Okay? So you don't have to do anything. And yeah, they're there. So let's go back to the slides first. So there's also more. You know, what you can do is, for example, you can use Ringo to back up John. John is a master, is a primary, and then back up John in George, and back up Paul in Ringo through geographical redundancy. Okay, you can have a cross setup. Of course, I mean, this was just a short introduction. You have more time. You can replay everything and in a better way, because you know the screen here was not perfect. So there's links to all the sessions. And you have to set up the frequency of the backups. Usually once a week is fine. You need to set up retention policies. With barman, it's very simple. You have 2 methods. One based on number of backups. One based on time or point of recoverability. Okay, it's similar to RMAN if you come from Oracle. You can use archive command as well. So not just wall streaming, you can use both, or you can use one or the other. We have barman wall archive that helps you with that. You can also perform streaming backup. We didn't look at that, but you can perform point-in-time recovery. You can specify a target. We just did to create a standby full recovery, okay? But you can say, I want to stop at 4 or 5 today, okay? We had a support incident 2 days ago. They had to do point-in-time recovery and they used barman, okay? So monitoring. It is very important to add monitoring of barman to your infrastructure, okay? So what we're working now, we separated the library, and we created a separate package so that we can start working on direct S3 support in barman. So these are applications that you will see in barman CLI from 2.9. So for example, if you have a Postgres database in the cloud, you can directly copy to S3 and recover from S3, okay? Similar to WAL-G. We did this because the next step is to actually integrate these in barman itself, so that you can add a multi-tier setup. So that, for example, you've got the last full backup locally. Then you've got 3 or 4 compressed tars locally, and then you have all, for long retention, all your backup data in S3, so tier 3. Okay, that's where we're thinking of going. So finally, I used the Beatles, so I decided to look at the song titles of the Beatles, and I discovered that the Beatles had thought about disaster recovery. Okay, so I had fun, to write this set. So I'm down. Okay, you know the song. Yesterday, my PostgreSQL cluster had a storage problem. I can't bring it up. Don't let me down. You know the song. Okay, you can't do that. I should have known better that I have no backups. Help! Please get back my Postgres database. I've got a feeling I've lost all my data. I'll cry instead. Okay? Recovery is now a long and winding road. Do you want to know a secret? I have learned my lesson now. We can work it out. It is going to be a revolution. I will now take backups 8 days a week. I'm so bad at singing, sorry. Oh, here comes the sun. See? And with geo redundancy and cloud storage, it is going to be here, there, and everywhere. From me to you, now I feel fine. Sincerely yours, the fool on the hill. And you should say, all you need is barman. So I want to thank, Barman development team, my colleagues at Second Quadrant, Rubens and Anna. But this guy here, if you have time, look for rule number 6. Don't take yourself too damn seriously, okay? It's an interesting book, and as you can see, I didn't take myself too seriously today. And there's a video about that. I encourage you to watch that. And yeah, we're hiring, so if you're interested, I would like, you can talk to me about this position. It's for support. And Simon and Johnny, they say hi. They're not here today. We released this book today, okay? These are the links of all the ASCII-Cinema, I don't know how to pronounce that. ASCII-Cinema, as Giulio said, which is terrible. And yeah, thank you.